Okay, this is going to be Seasons Part 2. Here's the picture I ended up with last time, talking about the dates, the times, how many daylight hours, how many nighttime hours we would experience, as well as talking about the North Pole and the South Pole, or leaning toward or away from the sun. You guys have all seen this picture of the Earth. We actually have a couple things here. Let me pick a color that's going to show up pretty well. We have the Earth's equator. And the Earth's equator is defined by the point that's halfway between the North Pole and the South Pole. So if you actually take the dot that's equidistant, you take this one that's equidistant, you take that one equidistant, all those connect them with a line. This is the only line that's not man-made. It's solely determined on the North Pole and the South Pole. The equator actually divides the world up into two hemispheres. One's called the Northern Hemisphere. The other one's called the Southern Hemisphere. This line right here is called the prime meridian. And the prime meridian, if you watched my celestial sphere, this is the point that runs between the north, your location, and the south. It's the center point where the sun crosses, where everything before it is called the anti-meridian, everything behind it is called the post-meridian. And this divides the world up into two hemispheres. If you're on this side, you're in the eastern hemisphere. And if you're on this side, you're in the western hemisphere. And we're located about right there. We're located 39 degrees north and 78 degrees west, so we're in the northern and the western hemisphere. Okay, these other lines that are on there, we have this line right here, and this is the northernmost migration of the sun's direct rays. Sunlight stays in between this line right here and this line right here. We've covered this line. This line is called a tropic. And this line down here is also called a tropic. This one is the Tropic of Cancer. And the way I remember this one is we live closer to the tropic you never want to get. It has to do with not the medical cancer, it has to do with the astronomical cancer. And this is the Tropic of Capricorn. And again, has to do with the constellation Capricorn. Okay, then we have this line up here. This line is called the Arctic. Circle. And this one down here is the Antarctic. Circle. And they actually represent the southernmost northern and the northernmost southern extent of no sun rays. So let me show you how these work in terms of these planets right here. Okay, here are our four Earths. Again, we have a sun in the center. Sometimes we're tilted toward. Remember the line which is way up here and there. This one is on the ecliptic. We're tilted 23.5 degrees from that. These are all tilted 23.5, all pointed to the same direction. Celestial sphere is pointed to Polaris, the North Star. We're rotating in a counterclockwise direction. So this is our 1, this is our 2, this is our 3, and this is our 4. This is the summer solstice, the one that actually happens in June 21st. And if you take a look at it, the sun's rays are coming directly into the Tropic of Cancer. So what's happening is the Arctic Circle. Let me draw a black line on there. Let me get a little I wish I could draw a nice straight line. Basically what happens is this is the side that is illuminated, this is the side that's not. So if you take a look at it, This northern hemisphere, the Arctic Circle, everything above it gets 24 hours of darkness. This Antarctic Circle, everything below it gets 24 hours of darkness, illumination, deillumination. The equator, located below, sun's rays are hitting the Tropic of Cancer. If you actually lived close to that location, you would find out that the sun would be directly at over your head at 12 noon as it crossed the meridian. This is that 12 hours of illumination. This is the 9 hours of, at least for us, way the heck up here, 24 hours of illumination up here, 24 hours of darkness down here. And then 3 months later, the Earth moves over to this location. Well, basically what happens is the side that's facing toward us is the side facing away from the sun. This is the dark side. The other side is illuminated. So probably what I should do is go in and, except not that color. I should go in here and color this whole side. Let me see if I can do it this way. Ink flow 100%. Looks more like an egg now than it did the Earth. Let me make this a little smaller. Do the same sort of thing over here. So there's the dark side. This is the totally lit up side. We'd have the same sort of thing over on this side, except that this is the side that's going to be dark. I don't like that, it's too dark. Whoops, too wide. So I'm going to get a line that looks something like this. Now I can get a little larger. This is the dark side because it's facing away from the sun. This is the illuminated side. And if you take a look at it, sun now is now hitting down here, the Tropic of Capricorn. The North Arctic Circle is not seeing any sunlight. The South Antarctic Circle is seeing total sunlight. The equator is a little bit higher than the direct. Down here is a little bit lower than the direct. If you take a look at our location again, here in Virginia, this is where we get the 9 hours of illumination, and we get the 15 hours of darkness, which gives us cooler temperatures. Then we move over here, and the sun, you can see, is hitting directly on the equator, where we get 12 hours of lightness and darkness. This is the, going from winter, this is the vernal equinox. This down here is the autumnal equinox. And the only thing you guys actually see that would be different is that this one, the days are getting longer. This one, the days are getting shorter. Other than that, they look exactly the same. And this one over here is the summer solstice. Again, the sun stands sun stands still, and this is the winter solstice. And this is named after the northern hemisphere because we came up with these names. Again, our winter is their summer, our summer is their winter, our spring is their fall, and their fall is our spring. How about our fall is their spring? So that's the way that one works. Going down here, all has to do with the angle of the sun. If you're located here by the equator, you can see the lowest the sun ever gets is 66.5. The highest is 90. Somewhere between this Tropic of Cancer and this Tropic of Capricorn, it goes somewhere between 43 and 90 degrees. And when they were 43, they're at 90. So it all has to do with the angle of the sun. You get more angle of the sun, you get more solar radiation. Okay, these three diagrams right here This is the summer solstice. Sun is hitting mostly in the northern hemisphere. You can see up here with the North Pole, it's completely lit up, 24 hours of daylight, 24 hours of darkness down here. Located about where we are, you can see we spend a lot more time in the illuminated than we do in the dark. If you go to the same down here, they spend a lot more time in the darkness than they do in the illuminated part. This is the summer solstice. How about let's do it this way. This is the summer solstice. This one here, these are the equinox, and again the equinox looks exactly the same. So this could be a vernal equinox, this could be the autumnal equinox. The northern hemisphere, North Pole is just seeing it, South Pole is seeing it. The entire planet gets 12 hours of darkness, 12 hours of daylight. This is the winter solstice. And this is actually from a site that's called Formulab. If you type in Earth Moon Viewer, Earth Moon Sun Viewer, you can actually see this site. I very largely shrunk these things down, didn't enlarge them. I think these are like 30% the regular size. This one is 40% the regular size. And again, it's all about the angle. I wish this thing was 39 degrees, but it's 50. That's someplace up above New York. But if you take a look at it, the sun goes from 63.5 degrees high all the way down to the lowest, which is 16.5. Our number is closer to 75 and closer to 25. But we get more sunlight than they do at 50. But it all has to do with the angle of the sun. If you take a look at it, the June solstice, the summer solstice, is the purple line. The equinox is the blue, and the winter solstice is the red, rising from west. Take that back. This is the east side, all the way to the west side. Things rise in the east. They cross the meridian, which is that point between the south, your zenith, and the north, crosses the zenith at the highest, and that would be for 63.5, 40 degrees, and 16.5 if you were at this location. If you move to the equator, sun goes from 66.5 all the way to 66.5 and doesn't get any lower than that. And notice that there is 23.5 degrees between this number and this number, or that number and that number. And that again has to do with the tilt of the Earth being 23.5 degrees from vertical. And then if you lived at the 90 degrees north, you'd actually find that the sun would stay in the sky 24 hours a day, 23.5 degrees up. On the equinox, it would be right on the horizon, 24 hours of daylight, and then the next day it's 24 hours of darkness. And the same thing for the South Pole, except that things would be different. This is the summer solstice. They would have it up there as the red line. The blue line would be here, and just like you can't see a red line in here, they wouldn't be able to see the purple line. And the last thing has to do with the solar radiation. Because the sun is higher in the sky and we receive more daylight, for the June solstice we receive much more sunlight on that one day than we really do any other time, although you can see that very next day. We go from June 21st to the 22nd, not a big difference, but you can see that the amount of solar radiation we're receiving is going down, and then you get to there, and it basically is 12 hours above and 12 hours below, and then it continues to shrink, getting lower and lower until we get to the summer solstice, where for the northern hemisphere, the smallest amount of sunlight we're going to receive, and then it actually gets higher and higher and higher as it moves up. So it has to do with the angle of the sun and how many hours of sunlight you do get. Okay, thank you very much. Bye.